Hello and welcome to this video. In this video, we will learn about operators a bit, and we will operate those operators on integers and floating point numbers to see how they work. So in Rust, operators are implemented as states. There are specific function names which you can implement for a type, and then the operator will be overloaded. For example, exclamation mark is a bitwise or logical complement, which is to implement not operator, you have to overload this function for your type. So in Rust, we see that operators are implemented using operator overloading. So not equal to is there, then it is partial equal method you have to implement. For percentage or remainder, then it is rem function. Percentage is equal to rem assign. So there is a list of operators which you can implement yourself with certain function names. Okay. Now, if we look at I32, we have got lots of functions implemented for it. Okay. So we will go through these at some point of time, but I'll let you know the important ones in the beginning. So we will not go and study all this in all the detail right now. Our first goal is to have a basic working understanding of how to write programs, because reading documentation only will not help unless you use them in practice. You will just not remember it. So for example, in my first video of Rust on integers, we had x and y as I8, and we were computing z by converting them to I16. But there is a way, there are three ways you can convert this, you can add this. For example, x plus iy, if you simply do, then it will throw an error while compiling. Okay, let's see, we are repeating this. So if I go to int type and we do cargo run, so it says thread main panicked at attempt to add with overflow. So what you can do is, instead of that, you can say check add, and you make it y. So this implements checked add. Okay. Now it returns none if overflow occurred. It returns an option enumeration type. So we just can't assign that to A. Okay. What we will have to do is, there are two important enums in Rust. One is result and another is option. So what we will have to do is, let B is equal to match. Match is an expression matcher. We match this against A, and it returns an option. So sum B. Sum is an enum type of in option A, and then it has to be matched with arrow function, and we simply return B, or rather C. And if it is none, we have to take some action. We have to say return -1, for example. Okay, and we put a semicolon here, and then we print B. So in this case, let's see how it works out. If you see, it computes self plus RHS and returns none if overflow occurred. So since it will return none in case of overflow, our B should be -1. So let's run this. You see, B is equal to -1. Then there is another type of addition, saturating add. The Rust analyzer will help you with a little bit of documentation. So saturating integer addition computes self plus RHS, saturating at the numeric mounts instead of overflowing. So for I8, the 100 plus 100, the upper bound in positive value would be 127. So it should print 127. So it printed 127. Now there is another one. There is something called overflowing add. Okay. So it will set a Boolean variable, which you can see in the function definition bool. It will tell us whether the value overflowed or not. And if it overflows, then it wraps around the maximum limit. So you can say that a dot 0 and overflow is equal to this, and in that we can say a dot 1. So let's see if this works, and it should print a dot 1 as true, and this would be 56, I believe. Yeah, 56, 200. So 128 and 200, there will be a difference of 72, and then 155 minus 172. Yeah, it should print 56, I believe. Yeah, minus 56. So you see, there are 3 addition functions for integers. Now for difference, it is not that problematic. It is similar, like addition. Let a is equal to y minus a. Let me say z is equal to y minus x. So it will print 0. Yep. But what if I make it minus 100? Then it will complain. It should overflow. So again, you can say that x dot check underscore subtraction. So instead of add, you have sub, and we can put it y here, and this becomes an option. It returns an option, so we have to match. Let a is equal to match, and then we say sum b arrow notation b, comma none, and for none we simply set it -1. Okay. So z, this should be z, match z, and we print a. So a is -1 because it has overflowed. Check sub will return none. So similarly, you can explore other functions like checked mul. Okay. Now we come to a bit of priority in operators. Suppose we have 2 such values, and let's make these smaller so that we don't get overflow problem. Let z is equal to, say, we want to say 5 plus 2 into 7. So this output would be how much? 49. Okay. And I have made it mut print ln. Inside double quotes we print z, and then we say z is equal to 5 plus 2 into 7, and then we have println, and we print z again. So in this time it should print 19. So it should print 19 and 49. So it printed 49 for the first one and 19 for the second one. So you should never rely on operator precedence. Always use these parentheses to declare your intent in an explicit manner that what you want to do. So similarly for division, say we want to perform an integer division. Let's see what will be the output of z. it will throw some warnings because I'm not going to reuse z here other than xy. So let's see. So it printed 1. Okay, and this is integer division. If you want to perform a float division, you make one of the operands float. So it says cannot divide integer by float. So Rust is very strict about types. So you will have to give .0 to divide. You just can't do integer division like that, and you get an F64. So if you want, you can specifically say that I want an F32. Okay. If you make that explicit, the precision will be less. And say you want to compute remainder, then you can say I want remainder, percentage operator will do. In this case, remainder should be 3. Okay. Expected F32 found integer. Oh, we have made this F32. So remainder is 3. So basic arithmetic is addition, subtraction, multiplication, division, and remainder. These are basic arithmetic operations. And then you have check, saturating, and overflowing version of these methods, these operators. So this is also applicable for F32. For example, if you want to see F32, then visit this URL. I will give you the list of all the functions for F32. So you have all the functions and constants involved with this. So I will not try to go all this just like that. When we use them, we will know that we need them, we will use them. So with this, I think I'll end this video. In the next video, I will start with the control flow operations, that is if else and for loops, and we will slowly build and learn our knowledge base by writing small programs. So most probably in the next video, we will see basic constructs of programming by which we can control the flow of a program and make logical decisions. So if you have found this video useful and informative, please subscribe to the channel and like the video. Also share as much as you can so that fellow programmers like you can benefit from this video. And if you have a comment or suggestion or you want to say something, make use of the comment box. And don't forget to switch on the bell icon, that is notifications. And thanks a lot for watching the video. Happy programming.